Question number 66. The correct solubility order in aqueous solution is lithium fluoride, sodium fluoride and potassium fluoride. Second option, lithium chloride, sodium chloride and potassium chloride. Then again, fluorides of alkali metals are compared, and here also chlorides of alkali metals are compared. It means what we need to compare here? First fluorides and then chloride to find out the correct order. So if we talk about the first option, there is lithium fluoride, sodium fluoride and potassium fluoride, and solubility depends on two factors we all know. One is hydration enthalpy, the second one is lattice enthalpy. And if hydration energy is more as compared to lattice energy, it's quite easy to break the lattice and the substance becomes soluble. Suppose I talk about lithium fluoride. In this case, lattice enthalpy is quite high because the size of lithium ion and fluoride ion are comparable and they have quite high lattice enthalpy. So in this case, hydration enthalpy is not sufficient for the breaking of the lattice. That is why solubility is least in this case. If we talk about sodium fluoride and potassium fluoride, sodium fluoride is more soluble as compared to lithium fluoride because in this case, lattice enthalpy is comparatively less as compared to lithium fluoride. So, more soluble sodium fluoride, while this potassium fluoride is most soluble. Why? Because in this case, lattice enthalpy is not that much high. That's why this would be the order of solubility. Further, if I talk about lithium chloride, sodium chloride and potassium chloride, the chlorides of these alkali metal. In case of lithium chloride, lattice enthalpy is not that much high as that was in lithium fluoride. So, lithium chloride has less lattice enthalpy, more hydration enthalpy, it is soluble in water. If we compare this with NaCl, lithium chloride is more soluble because lattice enthalpy is less as compared to this. Even hydration enthalpy is more in case of lithium chloride. So, this is more soluble. Further, NaCl if we talk about and we compare it with KCl, NaCl has more solubility. Again, the reason is comparison of lattice enthalpy and hydration enthalpy. So this is the order of solubilities for these two. Order of solubility. And on that basis, if you look at the given option, the correct order I have already written, you can easily choose the correct option. The correct option is option 1. And I am just going to choose it here as the correct option. Further, there is another question. Question number 67. Lithium is very strong reducing agent in aqueous solution because high reduction potential of lithium, high ionization enthalpy of lithium, strong metallic bonds in lithium, and high hydration enthalpy of Li positive ion. If we talk about lithium ion, it has very high hydration enthalpy, and that high hydration enthalpy overcome ionization enthalpy also. It means what would be the correct answer? Option 4 is the correct answer. That says it has high hydration enthalpy of lithium ion. So option 4 is the correct one. After this, question number 68. The incorrect decomposition reaction among the following is the first option, lithium nitrate dissociating to form lithium oxide, nitrogen dioxide and oxygen. This is the correct reaction. Next is 2NaNO3 is giving you NaNO2. Sodium nitrite is formed along with oxygen gas. This reaction is also correctly given here. If we talk about the next one, magnesium nitrate is there. It's forming magnesium oxide, nitrogen dioxide and oxygen. This reaction is also true. And further, if we talk about the fourth one, calcium nitrate is dissociating to form calcium nitrite and oxygen. This is the wrong statement because group 2 elements form their nitrate, and these nitrate when decomposed they form oxides instead of nitrite. That's why this reaction is wrong, and I'm just choosing it as the incorrect decomposition reaction. After this, question number 69, the calcium hypochlorite is. If we talk about calcium hypochlorite, the actual formula for this is CaOCl whole twice. This is the correct formula for calcium hypochlorite. So I'm just choosing it as the correct one. The answer for this question is option 3. After this, Question number 70. Which of the following is not a constituent of Portland cement? If we talk about Portland cement, it consists of silica, SiO2, calcium oxide, that's lime, and alumina also, Al2O3. These three are the main constituents of Portland cement. But if we talk about Li2O, this is not a constituent of Portland cement. And that's why option 2 is the correct option for this question.